So before starting the Lagrange interpolating polynomial, I'll tell you what will be your interpolating polynomial. That what do you mean by interpolating polynomial? So it means if you have if n plus 1 data points are given namely x naught y naught, right? x1 y1 up to so on xn yn. So these points are given to you. Then the target is to find. Then the target is to find a polynomial. So the target is to find a polynomial px of lowest degree which passes through the set of given points. The set of given points. Here y naught is nothing, that means we have given n plus 1 data point. So you can notice over here we have x naught and y naught and it is going up to xn and yn. So we have n plus 1 data points, right? So here y naught is nothing, that means the function value at x naught. So the function is unknown to us, that is known to us, right? That is not known to us. So that means the data point, that I know only the value at the x naught, the function value is at x naught. So what is the target? So we have to find a polynomial px which will be of lowest degree that will pass through the set of given points. That means at the nodal points, the value of yi will be equal to the polynomial at xi for all I is equal to 0, 1 to n. That means we have x naught points. So the polynomial will pass through from these points. That means yi will be same as the polynomial at xi. So this polynomial which you will find, that means this polynomial. So this polynomial px. So this polynomial px is nothing but is called interpolating polynomial. So this polynomial is nothing but this is called interpolating polynomial. And moreover, the degree of px will be less than equal to n, right? So suppose you have n plus 1 data points, right? So what will be your degree? Your degree of px, that means जो आप polynomial fit करोगे अपने डाटा के लिए, उसकी डिग्री n plus 1 डाटा पॉइंट्स के लिए लेस देन इक्वल टू n होगी. And so now the question arises that why my degree should be less than equal to n, right? So you can notice over here, suppose if you have any data points, so this will be the line. इस line की degree क्या होगी? That the degree of line, you know that the degree of line is 1. That means you have 2 data points. That means you have n plus 1, that is equal to your 2 data points, right? And you have the degree as your 1. So this is the degree of px is equal to 1, right? So why the degree should be less than equal to n? And it should be because when you have any 2 data points, we have to find a polynomial जो आपकी lowest degree की होगी. Why? क्योंकि आप ऐसा, जैसे आपके पास 2 points हैं, so you can have a polynomial that can have more than 1 degree. So you have to find a polynomial which is of lowest degree. So 2 points को आपके connect करने के लिए the best possible way is to join by a line. So here in this case your degree will be n. So what happens? Why the degree should be less than equal to n? Suppose you have 3 points, right, which are collinear. So you have now here 3 points, right? This is 1 point, this is 2 point, this is 3 point. So the best fitted line, that means the lowest degree. तो यहाँ पे आप अपना डिग्री 2 का फिट करने के बजाय आप लोएस्ट डिग्री क्या आएगी, दैट यू विल हैव अ लाइन which will pass through 3 points, right? So here your degree is not equal to 2, but here your degree is less than equal to 2 for your n plus 1 data point. That's why the degree of the polynomial should be less than or equal to 1, right? So for these points, and the same will hold for everything. So we should have a degree of polynomial. If we have n plus 1 data points, then we will have a degree that will be of lowest possible degree, that will be of 1. So first, now to start the Lagrange interpolating polynomial, we will first find first degree Lagrange interpolating polynomial. Once you able to find first degree Lagrange interpolating polynomial, then we will generalize it for your n plus 1 data points. First degree interpolating polynomial, or you can say this is your linear Lagrange interpolating polynomial. Either you can say first degree or Lagrange interpolating polynomial. So now we are fitting linear Lagrange interpolating polynomial. What we have studied, linear means the degree will be your 1. So that means if degree is 1, but we have said that if we have n plus 1 data points, we can have a degree at most less than equal to 1. So when you are talking about linear, that means you have points, let x0, y0 and x1, y1 be two distinct points, such that the function value at x0 is nothing y0 and the function value at x1 is nothing but this is y1. Then the interpolating polynomial, which will pass through these points, which will pass through these 2 points. We have 2 points, that means हमारे पास डिग्री क्या है polynomial की 1. So what will be our polynomial? That will be nothing but a0 plus a1 into x. So if we can know what will be the value of a0 and what will be the value of a1, we are done, right? So when we are done, that means for every x, I can have the value of the I can have the value at for every x, right? So we will use the concept that since by definition of interpolating polynomial, what it says that the polynomial value at the nodal points is the same as the function value. That means P1 x0 is nothing but the value at y0 and y0 is nothing the function's value at x0. And the P1's value at x1 will be nothing but y1 is equal to function value at x0. So if we use this notation, if I substitute x not in place of x, so what will be my P1 x0? What will be my P1 x0? That will be nothing but a0 plus a1 into x0. That will be equal to your function value at x0. And what will be my this value? When I substitute x1 on place of this, so that will be my nothing a0 plus a1 x1. That will be your function value at x1. So now you have two equations in two variables that you can easily solve. You know the value of x0, x1. You know the value at function x0. So when you will do the subtraction, right? When you will do 1 minus 2, right? So what you will get? you will get nothing. A naught will be cancelled out, so you will get x naught minus x1. This will be nothing but function value of x naught minus function value at x1, right? And when you solve this, you will get a1, that will be your function value at x naught minus function value at x1 divided it by your x naught minus x1. So now you got the value of your a1. The rest is to find the value of a naught. So we can use substitution. Substitute a1 in any of the equations. Suppose I am substituting in a1 in one equation. So I'll have a naught plus a1 into this quantity, that this is my f of x naught minus function value at x1. This is nothing but x naught minus x1 into your x naught. This is equal to function value at x naught. So when you will solve, you will get, this will be nothing but function value of x naught minus this quantity. It will come in the subtraction, so that is nothing but f of x naught minus f of x1 divided it by your x naught minus x1 into your x naught. So when you will solve, you will get x a naught, this will be f of x naught into x1 minus function value at x1 into your x naught divided it by your x1 minus x naught. So now you got the value of a1 and a naught. So what will be my polynomial? So now I have the polynomial. My a naught value is nothing but this value, function value at x naught x1 minus function value at x1 into x naught upon x1 minus x naught plus a1. What is my a1? That is my f of x naught minus fx1 divided it by my x naught minus x1 into x. We have this polynomial. When you will solve this polynomial, you will get, this is x minus x1 upon x naught minus x1 into function value at x naught plus x minus x naught upon x1 minus x naught into the function value at x1. So the quantity, this I can write p1x, this is my L naught x, function value at x naught plus L1x, this is the function value at x1. And these L naught and L1, these are called Lagrange fundamental polynomials. So the whole is interpolating polynomial, but these, the value of L naught, L1 are called Lagrange fundamental polynomial. Right? So when we are doing this, right? So you can notice one thing over here. So you just can write down or remarks, right? So whatever you have L naught and L1, so first remark is that your L naught x plus L1x, that will comes out to be your 1. When you will do this addition x minus x1 and this, all this addition, when you will add, it will result into 1, right? And when you have L naught into x naught, right? And L naught x1. So if you substitute x in place of x, you will substitute x naught. So what you will have, x naught minus x1, x naught minus x1. So this will give you cancel out. That means this will be 1. When you have L naught, जब आप इसमें x की जगह x1 डालोगे, so you will have x1 minus x1, that will be equal to your 0. The same thing you can notice for your L1 of x naught. L1 में जब आप x की जगह x naught डालोगे, so it will give you 0, and when you will substitute L1, x की जगह पे आप x1 रखोगे, it will give you 1. So अगर आपका ये है, हम ये कह रहे हैं कि ये polynomial बनेगी, that means x1 is the root of, हम यही बोलते हैं ना root, जहां पे मेरी x की वैल्यू 0 हो रही है, that is my root. That means here at the polynomial, your x1, at x1 it is coming out to be your 0. So x1 is the root of L naught x, and from here you can conclude that x naught is the root of. So your x naught is the root of L1, right? So next, so the example over here is, if you have example, determine the Lagrange interpolating polynomial. Determine linear Lagrange interpolating polynomial that passes through the points which are given to you, that is your 2, 4 and 5, 1. So you have 2 points given over here. That means you will fit your linear polynomial over here. So by the linear polynomial formula, so you have P1x is equal to your L naught x into function's value at x naught plus L1x into function's value at x1. So what you have, L naught x, this is equal to your x minus x1 divided it by x naught minus x1 into function's value at x naught plus L1. That means x minus x naught into x1 minus x naught into function's value at x1. So these points over here, if you can see, this is your x naught point, this is your y naught, this is your x1 point, and this is your y1. So you have x minus x naught. That means x minus x1. You have over here, this is 5 divided by x naught minus x1. So you have 2 minus 5. What is the function's value at x naught? 4. So you have 4 over here plus x minus x naught. X naught is 2 and divided it by x1 minus x naught. That means you have x1 as 5 minus and x naught is your 2. Function's value at x1. So you have 1 over here. So if you will solve this expression, this is coming out to be your minus x plus 6. So you have polynomial at this. Now because this is between the interval 2 and 5, and if I want to evaluate any value, say suppose I want to evaluate 2.2, that means here I will have minus 2.2 plus 6. Is it clear? Yes or no? So you have only value at 2 and 5. You have fitted your polynomial in these points so that you can find any value between 2 and 5. Is this clear? Yes or no? So you can see from here at the data points. Data points आपके क्या हैं? 2 and 5. If you will check by this polynomial, P12 आपकी वही value आएगी जो आपको data में given है, minus 2 plus 6, that is your 4, and P15, that will be your minus 5 plus 6, that is equal to 1. So at your data points, your polynomial value is same which is given to you. Is it clear? Yes or no? One more thing you can notice from here, because you are saying this is your Lagrange's fundamental polynomials. So here you can see from here that this satisfies the property. If you check for L naught x naught, what will be your L naught x naught? इस टर्म में अगर आप पुट करोगे x naught, क्या होगा? यही आप कह रहे हो ना, दिस इज योर L naught. x naught minus x1, x naught minus x1, तो आपका क्या हो जाएगा? 1. एंड L naught into x1 आपका कितना होगा? x1 minus x1 क्या हो जाएगा? 0. The same you can see from here. L1 x naught आपका कितना होगा? L1 x naught, x1 minus x naught. This is your L1. This is your L1.
L1 x नॉट पुट करोगे तो क्या होगा, x नॉट माइनस x नॉट 0 एंड योर L1 x1 कितना होगा, x1 माइनस x नॉट कितना हो जाएगा 1. सो यू कैन सी फ्रॉम हेयर, आप ये आपका एक फंक्शन ही तो बना, x में फंक्शन है ना, दैट मीन्स x1 इज द रूट ऑफ L1. यही कहते हो ना रूट के लिए, जहां पे फंक्शन की वैल्यू 0 हो जाती है वही आपकी रूट होती है. एंड हेयर x नॉट इज योर रूट ऑफ L1, sorry, L naught over here. Fine. So here your x1 is the root of L naught and here your L1x is the root of x naught is the root of L1. Is this clear? Yes or no? 2 points के लिए clear हो गया. Polynomial क्या होगी? Any doubt in 2 points? Yes, Joddeep, Mayank. Any doubt? No. Should we proceed for n plus 1 points? So now you have done it for your 2 points. So next we are doing the nth degree Lagrange interpolating polynomial. Lagrange interpolating polynomial, that means अगर आप nth degree की बात करो, that means you have n plus 1 data points. Yes or no? Fine. कैसे points हैं वो, इस तरह की x naught, y naught, x1, y1 up to so on. किस तरह के पॉइंट है, xn, yn. और ये जो आपकी y वैल्यूज हैं वो क्या है, बेसिकली that are equal to your yi is equal to functions value at xi for all I is equal to 0, 1, 2 up to n. Is it clear? Yes or no? Fine. So here you have total n points, xn, yn and x naught, y naught is including, so you have total x naught. तो जो आपकी पॉलिनोमियल होगी Pnx किस तरह की होगी, a naught plus a1x plus a2x square up to so on an xn, इस तरह की पॉलिनोमियल होगी. जब आपने लीनियर का फॉर्मूला किया, लीनियर के लिए आपने क्या लिख दिया, a नॉट को किससे रिप्लेस कर दिया, l नॉट x से, a इसको किससे रिप्लेस कर दिया, l1 से, और x की वैल्यू आ गई x नॉट fx1 आपने कह दी. दैट मीन्स जो आपका फॉर्मूला बना था p1x वो क्या बन गया था, l नॉट f ऑफ x नॉट प्लस l1 फंक्शंस वैल्यू एट x1. द सेम जो हमारी पॉलिनोमियल यहाँ पे बनेगी वो मेरी क्या पॉलिनोमियल बन जाएगी, दैट इज माय l नॉट x फंक्शंस वैल्यू एट x नॉट, l1x functions value at x1 up to so on ln function value at xn. This is also x. तो यहां से आपकी l नॉट की वैल्यू क्या होगी, वहां पे आपने l नॉट कैसे निकाला था, x माइनस वही वाला पॉइंट छोड़ दिया था जहां पे f ऑफ x नॉट आ रहा था. तो आप क्या होगा, x माइनस यहाँ पे आप क्या छोड़ दोगे, x naught you will leave here, so you will have x minus x1, all the products, x minus x2, x minus x3 up to so on x minus xn, divided it by, किससे डिवाइड कर रहे थे, x naught minus x1, x naught minus x2, x naught minus x3 up to so on x naught minus xn. So this will be your l naught x. L1x क्या होगा, दृष्टि, what will be my L1x? Yes, you please. What's your name? Kriti. Dhriti. Dhriti. Okay. So what will be my L1x? X minus x naught. Yes, you will leave the term over here x1. So you will have x minus x2 and all the terms up to x minus xn. डिनोमिनेटर x1 minus x0, x1 minus x2 and up to so on x1 minus xn. ith अगर लिखना चाहोगे LIX क्या होगा? x minus x0, x minus x1, x माइनस क्या होगा? I minus 1 वाली टर्म आएगी, I वाली टर्म नहीं आएगी. फाइन. So you will omit that x minus xn. Divided it by xi minus x0, xi minus x1, xi minus xi minus 1, xi minus xi plus 1, up to so on xi minus xn. क्लियर है यहाँ तक? L0, L1, Lx आपके कैसे आ रहे हैं? यहाँ तक क्लियर है सबको? फाइन. सो दीज आर योर पॉलिनोमियल्स. यहाँ पे ये भी वही प्रॉपर्टी सेटिस्फाई करेंगे जो आपकी वहां पे सेटिस्फाई कर रहे थे. Li इंटू एक्स जे मेरा क्या होगा? अगर मेरा j इक्वल टू आई है और j मेरा नॉट इक्वल टू आई है, वहां पे क्या था मेरा? L नॉट इंटू एक्स नॉट कितना आ रहा था? L नॉट एक्स नॉट क्या आ रहा था? 1. Fine. So you have Lixj. When your j will be equal to I, you will have 1. When you will have j not equal to I, that will be your 0. This property it will satisfy over here, and moreover, it will also, the property also was there that if you will sum up L0 x plus L1 x, that comes out to be your 1. Fine. The same you have over here. If you sum up these Lix, this will result it into 1. Next, you can also write it in the simpler form. ये आप कैसे लिख सकते हो? This is Lix. This is equal to your product of j is equal to 0 to n x minus xj, and here I should give the condition that my j is not equal to I. xi minus xj. Is it clear? Fine. So you can also write in the simpler form. यहाँ पे मेरा Li में मेरा x minus xi तो नहीं है. अगर मैं इसको x minus xi से मल्टीप्लाई करूं या x minus xi से डिवाइड करूं, कोई फर्क पड़ेगा? No. So you can, what I am naming this equation, I am giving as, this is name as w of x, just to write it in the simpler form. Because you have a quiz, then you should know all the forms. So if I am writing here, this is my w of x, and this I am writing x minus xi. Now since if you have like this terms x minus 2, x minus 3, x minus 4 like this, if suppose this is my wf, डेरिवेटिव क्या होगा इसका? w डैश 2 पे क्या डेरिवेटिव होगा? क्या करोगे? यहाँ पे प्रोडक्ट रूल लगाओगे. फाइन. तो क्या होगा? x माइनस 2, x माइनस 3. यहाँ पे 4 वाला डेरिवेटिव नहीं, 1 होगा. सेम x माइनस 2, x माइनस 4, डेरिवेटिव यहाँ पे क्या होगा? 1 प्लस x माइनस 3, x माइनस 4, यहाँ पे डेरिवेटिव 2 वाला 1 होगा. तो जब आपने 2 पे वैल्यू निकालनी है, कहाँ पे जब आपका वो 0 होगा, ये वैल्यू आपकी 0 हो जाएगी. सेम ये वाली वैल्यू भी आपकी 0 होगी. जहां पे आपने वेयर यू हैव टेकन द डेरिवेटिव ऑफ x माइनस 2 टर्म, वो आपकी क्या रहेगी? नॉन जीरो. सिर्फ वही वाली टर्म रहेगी. सो इफ यू राइट इट दिस टर्म, कैन आई राइट दिस w डैश xi? जहां पे आप x माइनस xi का डेरिवेटिव लोगे, वहां पे वो टर्म आपकी नॉन जीरो देगी, बाकी सारी जगह आपका xi आ रहा होगा. So if you will subtract all the items that and xi minus xi will be there, then it will be 0. So at the derivative term where your x minus xi derivative will be there, वो सिर्फ आपकी नॉन जीरो होगी. ये फॉर्म क्लियर है? Yes or no? So this is just the notation. फॉर्मूला आपका वही है कि आपने L0 x निकालना है, L1 x निकालना है, L2 निकालना है. Just substitute and you will get the answer. Is it clear up to here? Yes or no? So you can see the example if you have. So if you have data points given to you as x, y, this is function, this is 0 and the function's value at 0 is 1. This is 1 and function's value is 3. And this is your 3 and this is your 55. So you have to fit your Lagrange interpolating polynomial in this data. So you have total here n plus 1. You have here 3 points. What will be the at most degree of p and x? 2. So p and x will be of degree 2, at most degree 2. So आपका फॉर्मूला क्या है? p2x आपकी क्या होगी? a0 plus a1x plus a2x square. That is equal to your L0 x function's value at x0, L1x function's value at x1, L2x function's value at x2. L0 आपका क्या है? x minus, what is L0 x? X minus x1. x1 is your 1. X minus x2. x2 is your 3. x0 is 0 minus 1. 0 minus 3. Function's value at x0 क्या आएगी? 1 plus x minus x0. 0. X minus x2. Functions, this is 1 minus 0 and 1 minus 3. Function's value at 1. That means that is your 3 plus x minus 0, x minus 1, divided it by 3 minus 0, 3 minus 1 and function's value at x2. That will be your 55. So if you will calculate, this is coming out to be your 8x square minus 6x plus 1. So if you want to calculate the polynomial's value, suppose at 2.2 point or 2.5, what you will do, you will substitute 2.5 over here. That means 8 into 2.5 square minus 6 into 2.5 plus 1 and you will get your answer. Clear up to here? Yes or no? Any doubt? So since you are doing your Lagrange interpolating polynomial, there can be other method also. जैसे आप polynomial इस तरह fit कर रहे हो a0 plus x1 x a1x plus a2x square, you can fit it in another form. a0 plus a1 जिसके centralized point के आप around power series लिखो. So but whatever method you will follow, you will always get a unique interpolating polynomial. कोई भी मेथड लगाओ, Lagrange न्यूटन डिवाइडेड डिफरेंस, क्यूबिक स्प्लाइन, कोई भी मेथड लगाओ, हर्माइट, फॉरवर्ड डिफरेंस, बैकवर्ड डिफरेंस, यू विल ऑलवेज गेट योर पॉलिनोमियल. आपके पास हमेशा जो पॉलिनोमियल आएगी वो यूनिक आएगी. फाइन. सो दिस इज द नेक्स्ट थ्योरम. प्रूव दैट, इस नेक्स्ट क्लास में नेक्स्ट टॉपिक स्टार्ट कर लूंगी, ये कुछ भी नहीं है इस थ्योरम में. ठीक है. प्रूव दैट फॉर गिवन a real valued function f of x and n plus 1 distinct points x0, x1, xn, then there exists a unique polynomial Pnx of degree less than equal to n, which interpolates which interpolates the unknown function f of x at given points x0, x1, x2 up to xn. Now what this theorem is saying कि जब भी आपको n+1 डाटा पॉइंट्स गिवन है, डिस्टिंक्ट पॉइंट्स गिवन है x0, x1, xn, और आपको फंक्शन आपका पता नहीं है, जो आप पॉलिनोमियल निकाल रहे हो, कोई भी मेथड से निकालो, वो हमेशा ही यूनिक पॉलिनोमियल होगी. फाइन. दैट मीन्स नाउ वी आर गोइंग, द प्रूफ इज ऑल्सो वेरी इजी. So because they are saying that there exists a unique polynomial, so let I am taking two polynomials Pnx and Qnx be two interpolating polynomials. जो भी मुझे डाटा पॉइंट्स गिवन है x0, x1, xn, उन पॉइंट्स के लिए मैं क्या लेके चल रही हूँ कि Pnx और Qnx मेरी क्या है, तो इंटरपोलेटिंग पॉलिनोमियल है. अगर Pnx और Qnx मेरी इंटरपोलेटिंग पॉलिनोमियल है, तो Pnxi मेरा क्या होगा, व्हाट विल बी माय Pnxi? 0 for I equal to 0, sorry, that will be equal to your yi, function's value at xi, for I is equal to 1 to n, and Qnxi भी क्या होगा, yi, which is equal to function's value at xi for all I is equal to 0, 1, 2, n. Because we are taking two polynomials, then we are defining one polynomial Tnx, which is the difference of these two polynomials. अब जो आपकी Pnx है, फाइन, और Qnx है, वो आपकी इंटरपोलेटिंग पॉलिनोमियल है, और Pn की डिग्री कितनी होगी, द डिग्री ऑफ Pn इज एट मोस्ट n, दैट मीन्स लेस देन इक्वल टू n. Qn की डिग्री भी क्या होगी, अगर ये भी लेस देन n है Pnx, Qnx भी लेस देन n है, तो Tnx की डिग्री क्या होगी, what will be the degree of Tnx? लेस देन इक्वल टू n. इससे ज्यादा तो नहीं हो सकती. बट इफ यू चेक Tnx नॉट, Tnx नॉट क्या होगा आपका फंक्शन, Tnx नॉट माइनस Qnx नॉट. नोडल पॉइंट पे पॉलिनोमियल की वैल्यू क्या है, y नॉट. Q भी वैल्यू क्या देगा, y नॉट. तो क्या आएगा आंसर, Tnx1 भी क्या होगा, यस क्या होगा, 0 अप टू Tnxn, xn भी क्या होगा, 0. दैट मीन्स Tn हैज zeros x0, x1 एंड xn. टोटल कितनी जीरोस होगी Tn की, n+1. कोई भी फंक्शन कह रहे हो आप x² - 2, x इज इक्वल टू +-2, रूट उसके 2 हैं, 2 से ज्यादा हो सकते हैं नहीं. यहां पे आप क्या कह रहे हो कि डिग्री उसकी क्या है, लेस देन n, बट वो 0 कितने पॉइंट्स पे हो रहा है, n+1. दैट मीन्स ओनली कंडीशन क्या रहेगी, देयरफॉर बट Tn हैज डिग्री लेस देन इक्वल टू n, देयरफॉर Tnx आपका क्या हो गया, 0. दैट मीन्स Tnx माइनस Qnx, that is equal to your 0. That implies you have unique interpolating polynomial.